Great. Okay. Yeah. So welcome to today's session. So I wanted to talk a little bit about the ASM and that combination with OPC-UA LADS. As you know, there has been some activity in the recent years to not only have a standardization in the data formats part, but also on the instrument automation part. And there are actually two activities ongoing. The OPC-UA LADS standard has been released end of last year, and we are currently working on another OPC-UA standard called KAISI, where major analytical vendors, Agilent, Thermo, Shimatsu, and Waters are working together on OPC-UA based device driver concept to be able to exchange drivers easier. So, and I'm the chairman of this KAISI activity, and from this perspective, I got exposed in the recent years on OPC-UA. And OPC-UA is well known for its communication capabilities. But there's also an information model behind that, and this is from my perspective a hidden gem. So so we'll get a little bit more insight into that. Okay, so oops. So we have seen, and this is no secret, is that the digital lab requires standardization in data formats and communication. And Allotrope plays well in the data format side, but the communication side is just a race coming up. So there are various activities in the communication part, and so we are favoring the OPC-UA standardization. But to bring them both together, the Allotrope world and the communication world, so that only this enables solutions. It's when you do just the data format side, not just the communication side, there's a lack of either communication or data format. So that's the content of my presentation today. I will give a short demo about what I will explain in the first part of it. And then I think there's steps further we might take regarding the Allotrope Foundation, which was already mentioned yesterday. So I already explained that. So data formats and communication both have to come together to make an overall solution for the lab. So what's the situation today? We have a data source which produces JSON or an ASM JSON object. We have to put it somewhere in the folder. The data consumer has to pick it up, has to deserialize it, and then can make access of that information. That's working, but it has some drawbacks. So you have to always go through a JSON file in a folder, and the JSON serialization and the transportation for high volume binary data is not really ideal. So if you think about mass spectrometry data that gets easily high volume, and if you have to serialize a JSON object with MS data, that's not really the way you want to send around such data. And so better would be first if you would have the possibility to do direct machine-to-machine exchange of data without having a persistence file in between. Then you would like to have for high volume data the choice for binary transport, but for other reasons you might want to use text or JSON-based format, since the consumer is easily able to handle JSON information but not binary. And then you want to have also some ecosystem around the data modeling. So today we have a JSON schema for ASM, but this is handcrafted. So you would like to have a little bit more sophisticated mechanisms to do the model designing of ASM and also generating the code based off the data model. So this is what you have to also, but everybody has to look for how can I get from my ASM JSON schema and some code that I can put the information into that data model and then serialize it. And so there's some idea to combine the data formats world and the communication world. So with one side, the Allotrope Foundation formats are playing a role, and the other side, OPC-UA is a great tool or great framework to build out such an infrastructure. And with the OPC-UA, there's also the information modeling coming. So what could be done is you could adopt the Allotrope data format, the ASM to the OPC-UA modeling, and then you get a lot of benefits. So you could do the transport over OPC-UA, and you could also expose the ASM content via OPC-UA interfaces you cannot do today. So just what you can do today is you get your JSON file and you can use it internally within your software component, but you cannot really expose it in a standardized fashion to the outside world. And so if might not be everybody familiar with OPC-UA, and there is a nice movie about 1 minute length, and I hope that plays now.
Now you're
okay.
It's coming on your computer.
The audio is probably not playing well, so I can send around the link, but it tells in a minute there is machine-to-machine communication. And it's not just IT or OT. OPC-UA is already established in the manufacturing world. It's available for Windows, Linux, iOS, and Android. And you can scale it up from very small processors to cloud ecosystems. So it's really platform independent, and there's a great community behind. And it's secure, so it has been checked that is a secure communication, and it's already used in various domains. So it's car manufacturing, food and beverage, oil, gas, and there are various use cases where it's already used today. It's vendor independent, scalable, secure. And you can read that. So, and I sent the link with the slide set. So therefore, that's what you basically get with the on a high level from the OPC-UA framework. So you get the information model, you get the communication, and you have several communication possibilities in parallel. So you have a session-based possibility with TCP/IP or WebSockets, and you have a session-less communication with publisher-subscribe pattern, what you can do via MQTT or AMQP, and with just recently the REST API functionality has been documented as well, and I will show that in the demo then. And so with that, there's also the encoding part of it, so you can choose how you want to have this information serialized. So you have the possibility to serialize it in binary or in JSON, or that's something that where OPC-UA is prepared for the future. Since it's an abstraction layer, you can put other encoding mechanisms below that. So if in 5 years another encoding technology comes up, you can hook it under the OPC-UA framework, and it's ready to be used for that. And now we should come to the LADS sign. It's the battery. Okay. Good. Let's go there. So LADS has been is a companion specification. So companion specifications are a defined set of data models for a certain domain, and there are many companion specs available, and the one for the laboratory and analytical device domain has been released end of last year. And there's a hackathon ongoing in Duisburg, which is not too far away, where they're doing this plug and play and development for LADS in the moment. So what is OPC-UA? So it's basically an application logic on top of various layers. So we have a serialization layer, security layer, transport layer. I won't go into the details by now. And it has been stable for many years. They have shown that they can extend the technology by new upcoming stuff, like they recently added JSON. And yeah, so they were also able to add WebSockets on the transportation layer. We always try to explain OPC-UA. I don't know if it's an ideal picture, but we try to do it with that. So with the Lego approach. You have basic bricks, wall bricks, angle bricks, curve bricks, arc bricks, and these are the different concepts which are exposed or provided with OPC-UA. And there is a basic OPC server. You can build your own basic OPC server. That means you can build your own house. With the companion specification, you can get predefined sets, so like the police station or the fire station. And so there's also other companion specification like way. So there's another set of buildings. And then there's a third kind of companion spec which offers another set of buildings. And with all these bricks and themes and houses, you can build your own city. So that's a higher level representation, how you could see that. Might not perfectly fit. I was mentioning that the OPC-UA information model is a gem, and there's an excellent recording on YouTube available from Jim Luce, who's CTO of the OPC Foundation, and he focuses on the information modeling. And I think that's really valuable to have a look at that. So how does the information modeling look like? So there is a basic set of types. And the important stuff is the structure, and you can build on top of the existing ones your own types. And that's what I did for the ASM. So you can probably see here, this is the common types for the liquid chromatography. It's a subset for the liquid chromatography ASM. And with these types, which are kind of patterns, you can build your overall ASM JSON structure then. And so that's what's behind the measurement document type. And so you can use these types within your own type. So for instance, in the ASM measurement document, we have used then the sample document, the injection document. So the ones who are familiar with the liquid chromatography might recognize these types. And so these variables can be, these types that I just mentioned can be used in variables, and these are used in OPC objects. And on the right side, you see an example how this hierarchical tree of objects can look like. And here we have then the under the device set some devices, and you will see in a minute how that plays together with the LADS world. Coming back to the original topic, so we wanted to have the Allotrope Foundation world combined with the OPC world. And so OPC-UA offers then, as I mentioned, a secure channel combination. So on the left side, you would have the data source, and then you would have a serializer that turns that information either into a JSON or a binary. On the other side, you can recognize what it is, and you would be able to deserialize the same information and then make use of it. That's a secure and direct machine-to-machine communication, and you have the choice of doing this on a text or a binary basis. And you can do that in parallel. So while one channel is or one endpoint is using the binary serializer, you can in parallel do the JSON with another endpoint. And you can still include the functionality to persist the allotrope information in JSON that's still given. And so what you could do with that is you could either transport whole ASM information within a respective type from the source to the target. Or you could also have just subnodes of this written or read. And so, for instance, if the data consumer wants to have just some small pieces like the chromatogram or the injection information, they could just read this piece of information without having to need the overall infrastructure, which is a drawback today. So if you want to have these two pieces of information today from an ASM, you have to transport the whole ASM from the left to the right side. They have to deserialize it. And with that approach, you can really pick just a piece of information. And for instance, where this is used today is in the biopharma process control environment, where they're running analytical instrumentation runs. And after the run, they want to have just pure information. And this is where OPC-UA is established today. Further benefits. So OPC-UA is ready for the cloud, and with the OPC-UA, you also get basically a REST API for free. So there has been an activity in the last half year, the OPC Foundation, to document the REST functionality, and with that you can also get the optional possibility to query that information via GraphQL. What could also be done is when we have the ASM data models, we could specify them as OPC-UA companion specifications, which make them a little bit more formal. OPC-UA itself is an EIC standard. I think the companion specs are not part of the EICs, but these specifications would then be more formalized rather than just exposed as a JSON in an environment as it is done today. And with OPC-UA, you get data modeling tools. I can show one. You get the source code generator for free, and this is where the Allotrope Foundation doesn't need to take care of this anymore. So since today you have to take care of generating the JSON schema and also the stuff behind it, and you would get this for free since there is a strong community of, I would think, currently there are over 900 community members participating here in the OPC Foundation. And you're ready for future prepared technology. So ASM today is completely based on JSON. If a few years from now you might change to something different, that's probably hard to do. Picture. So, okay. So here you see on the left, this is an information model from a LADS device. Here there are several folders. I cannot go into that details now, but under functionality, you can see the functional part of the analytical device. You can see here the typical devices of an HPLC. And then there is also the area of a program manager, which hosts the information of a result. So that means when you have done an analytical run with such a device, you will find the result in a result set at this location. And this is where we would hook in the ASM objects for the liquid chromatography space. And so, oops, this is the current situation of the LC ASM model in an OPC-UA fashion. So you can find all the pieces that are currently defined in the liquid chromatography ASMs. On the left side, there's the top level, and then it goes on the right side into the details. And it's basically the same as the JSON schema, but in an OPC-UA information modeling language. So this is the second part of it. So I was able to really transport every structure and each enumeration from the ASM JSON world into the OPC-UA world. And with that, I was able to generate code. And so that's basically how it goes. It's not a big thing to do that. So now let's go into the demo. Just have to switch. Use the stick and to test. This is the time. Okay. Okay. I have taken some LCMS data and I turned this into the it's gone now. Okay. Just a minute. So this is the data I have. I will show then in the OPC-UA world. So it's an liquid chromatography mass spectrometry run, which has been transformed into in ASM. So we're working on a prototype for that. And this is the viewer for the ASM. Others might look as familiar, since it's also the viewer for the ADF. And then you can see here, this is the 3D UV data, and this is also the mass spectrometry data with the mass spectrometry files. And this is basically, this data is already loaded into an OPC server, which is running here in the background. And so what you can do with the for OPC-UA, there are a lot of viewers available. So this is one from a company called Unified Automation. And here on the left side, you can see that here, this is the information modeling instantiated. So you can see then here, this is the structure I have shown before. And under result set, you will find here my example run, which is then the ASM liquid chromatography structure. So this is basically loaded here into that structure. And here, and what you can do in this viewer, you can drag and drop stuff from the left side to the right side, to the middle layer, to the access data view layer. And then you can see here, this is loaded via OPC-UA into that line. So this is where I can get information via OPC-UA from the OPC server, which has loaded the ASM on the other side. And what's also possible is you can have this same information then on a REST API level. So what I did is I just had the REST gateway in front of this OPC server, and then you get the same information from OPC-UA interfaces via the REST APIs. Drill down into the same infrastructure as well, but with that you get for free then also the possibility to have this information accessed via REST. And with that, you can do a lot of other stuff. Okay, good. This is the information modeling tool. There are various available in the market. We found one from Siemens, which is on the other side for free, the most sophisticated one. With that, you can do this data modeling, and so you can see here on the left side there is the ASM peak data type. You can then do the data modeling. You save this information in a so-called nodeset2 XML, which is the way how the information models get persisted. And with this nodeset2 XML, you can then generate the code you need to instantiate that data or load that data in the various languages. Okay, good. So I think we're up to the time. Any questions? Oh, I think, oh no, I have still some slides. Sorry for that. It's the next one. So the question would be, if Allotrope and OPC-UA would like to join forces, I think the information modeling is ideal for the Allotrope ASM, and I think there are also possibilities to merge the ADF format into that one world. Also, the ASM, the OPC-UA data modeling is has a semantic approach. So it's also behind it, this information modeling. There is an idea of a network, of a graph. You have also the possibility to link properties with taxonomy. So what we have done is we have tagged certain properties in this information model with Allotrope terms. So you could search, for instance, for a flow based on the information you have in the Allotrope taxonomy. And so I think there are possibilities from leveraging the infrastructure. But I think the other thing that would be a strong message is if Allotrope and OPC-UA would join forces, then you would have a complete solution out of the box for data formats plus communication. And I think others have done this as well in the past, but I think with this combination, Allotrope plus OPC-UA, I think that would be a really good partnership. And there are others who are also participating in the OPC-UA world, and you can find a lot of well-known organizations that contribute to that. I think that's it for now.